All right, so this is transforming linear functions. And in pre-algebra, we did a unit on transformations. Transformations are when you take a shape and you can slide it, right? So you can translate, meaning slide it up or down or left or right. You can rotate it, which is turn it, right, like a clock. You can reflect it, which is flip it over. So in pre-algebra, we did that with shapes. In algebra, we're going to do that with linear functions, with linear equations. But the same premise, the same idea, the same concept works for both. So they're called family functions. And a family function are functions or equations, right? Because function is a different word for equation. A family of functions are functions or equations whose graphs have similar characteristics. Family functions are functions or equations whose graphs have similar characteristics. Maybe they have the same slope, but they have different y-intercepts. Or maybe they have different slopes, but the same y-intercepts. Or maybe their slope and their intercept are different, but they're both linear. Or maybe one's positive, one's negative. There are little changes between them, so you're going to have to be able to identify the changes. The parent function is the most basic function. It's where everything starts. The parent function is where it all begins. A parent function, or the linear parent function, is y equals x. And lots of times people have difficulty looking at that y equals x because it's in their mind, it doesn't look like it's written in slope-intercept form. It is written in slope-intercept form, but we don't see automatically the slope, and we don't automatically see the y-intercept. So let's rewrite it down here in slope-intercept form, right? Y equals mx plus b. And if I take that parent function, y equals x, y equals x, what's the slope? If it was 0, there wouldn't be an x, right? 0 x's disappears. There is an x. 1 over 1. And what's the intercept? 0. And this one is 0 because there's nothing written there, correct? And if there's nothing, that's a 0 value. So the slope is 1 over 1, and the intercept is 0. And I can graph that. My intercept is 0, so I start at 0. I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I want as many dots as I can because that's what makes a good graph. I've run out of room though, so instead of going up and to the right, I'm going to go down and to the left because -1 simplifies to +1. This is the parent function. It's the most basic, original linear equation. Everything is based off of this. Okay, so a transformation is to change from the original. Or the parent function. Right? I remember it by transformers, right? They can be one thing and then something happens and you change them to another thing. A transformation is changing from the parent function. So it starts out, this is what we always need to think of in our brain, the parent function. This is the original beginning of functioning. A translation is when you slide. So if you're sliding something, let's think about that. If I'm going to take this graph and I'm going to slide it, right? If I'm sliding it, is the slope changing? The slope isn't changing. What's changing if I'm sliding it? The y-intercept. It's a change in the y-intercept. So let's practice our translation skills. If I look down here, I have f of x equals x. Is that the parent function? Didn't I say the parent function was y equals x? F of x is the same thing as y. Don't forget that. F of x is the same thing as y. So what's the slope in this function? 1 over 1. And what's the y-intercept? 0. This is the parent function. Can you graph the parent function? Do it. The parent function is the basic one. If you ever see y equals x or f of x equals x, this is always it. It always looks like this. But then we're going to translate it. We're going to slide it. Does the slope change from the f of x or function of x equals x to f of x equals x plus 2? Did the slope change? No, the slope is still 1 over 1. Does the intercept change? What's the intercept now? 2. So let's graph it. We go up 2 to start our graph. All I did was slide my original parent function graph up 2 spaces. Nothing else changed, so try the next one. The slope did not change, it's still x, so it's 1 over 1. But my intercept is -3 now. So I go down to 3 and then graph my slope. This is translating a linear function. This one went down 3. That's the translation. If you just looked at this equation, y equals x minus 3, could you tell me what's going to happen to the equation? The intercept is negative 3, so it went down 3 spaces. The slope doesn't change. The slope is still 1 over 1. Let's talk rotations. What does rotate mean? To turn. A rotation is a turn. So if I'm going to turn a graph, what is involved in turning a graph? Is it the slope or the intercept that turns a graph? The slope turns it. It's a change in slope. Change in slope. So again, let's start off with our parent function. I know it's the parent function because it's f of x equals x, right? So my slope is 1 over 1 and my intercept is 0. That's my parent function. It's the very beginning, the basics. You should be able to graph the parent function really without a whole lot of counting by the end of this lesson. It's always the same. The parent function is always the same. So if I then add a different slope in, I change my slope. My intercept doesn't change, but I changed my slope. My slope is now 2 over 1, and my intercept is 0. So I still start at the origin, but this time, instead of going up 1 and over 2, I'm going to go up 2 and over 1. Up 2 over 1, up 2 over 1, down 2 to the left 1, down 2 to the left 1. And let's talk about this graph. It has a positive slope, correct? It goes up to the right. But what happened to the graph? It turned, making the graph what? What's a vocabulary word you could say about it? What does slope measure? The angle of it. We call it the steepness. It's steeper. I want you to take out this negative. That's a typo. It should just be 1/2 x. No plus 1 either. I started cutting and pasting evidently. Just y equals 1/2 x. What's the slope here? 1/2, so 1 over 2. What's the intercept? 0. So I put my point at 0, my origin, and from here I go up 1 over 2, up 1 over 2, down 1, backward 2, down 1, backward 2. So this turned again, but what happened when the slope was 1/2? It's less steep. So the bigger the number, 2, 3, 10, the steeper your line. The smaller your number, 1/2, 1/4, 2/3, the less steep your line, the more it flattens out. Which makes sense because 1/1 is perfectly diagonal. So if you get any bigger than 1/1, it's going to go up. If you get any smaller than 1/1, it's going to go down. And the last one, reflection. What does it mean to reflect something? Flip it. And this one's kind of hard to visualize because we've already changed our slope. We've already changed the intercept. How do we make our parent function flip over? Anna? Close.
Change them both?
Close.
The opposite.
It's the opposite. To flip it, you change the slope. You change the slope to make it the opposite. If it's positive, you change the slope to negative. A negative slope flips over. A negative slope flips over. So do the first parent function. Slope of a parent function is 1/1 and the intercept is 0. Perfectly diagonal through the graph is the parent function. In the next f of x equals negative x, our slope is negative 1/1, and our intercept is still 0. So 0. But here I go negative 1/1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, and so on and so forth. I'm going to completely change that third problem, so don't start it yet, because it doesn't work. Let's do negative 5/4 x. Y equals negative 5/4 x. Again, it has a negative slope, so I'm expecting it to be flipped over. I flip-flop it. Negative 5/4, and my intercept is 0. Do you expect, before you graph this, is this going to be steeper or less steep? I hear a little bit of both. And I think I hear a little bit of both because you're not simplifying. The fraction negative 5/4, right? If it was 5/4, that's really 1.25, correct? Which is larger than 1. The bigger the number, the steeper the graph. Just because it's a fraction doesn't necessarily mean it's going to be less steep. Negative 5/4, positive 5, negative 4. It's a little bit steeper than the parent function, right? The parent function is right here. This is a little bit steeper. So let's talk without graphing. Now that you've seen this via the graph, let's talk it through without graphing it. What's going to happen? How does this compare to the parent function? How does y equals 4x minus 7? There are two things that happen to it. What's one of them, Talon?
It's steeper.
It's steeper. What else is different about it? Damaris? Yeah, and it's down 7. It translates down 7. So it's gonna, I'm just estimating here, right? Here's negative 7, and it's gonna look a little bit like that. All right, let's talk about the next one. There are three things that are different about this next one. F of x equals negative 4x plus 3. There are three things that are different about it from the parent function, from y equals x. What are the three things that are different, Ella?
Gotta go up.
Okay, it's going to go up 3. It's translated up 3. What else is different about it? Anna? It's a negative, so it's reflected. It's flipped over. What else is different from y equals x? Safi? It's steeper. So if I was going to graph it, it's up 3. It doesn't go up to the right, it goes up to the left, and it's pretty steep. It's an estimate. Last but not least, how does that last one change from y equals x? What are the differences, Raina? Goes down 3. It's translated. And what else is different? Dylan? It's less steep.